Alright, so let's say you wanted to find out how fast something was going after following the specific distance. Okay? So here's my object falling through the air. Let's say it starts from rest, so that would mean its initial velocity. Draw that a little bit neater. Let's say its initial velocity at 0 seconds is 0. That means it's dropped from rest. And then each second it speeds up. So this would be 0 seconds. Let's see here. 1 second. 1, 2, 3, 2 seconds. 3 seconds. 1, 2, 3, 4, 5. Alright, so that's going to be a little bit long. I'll just do those dots. So this would be, wait, that's at 0 seconds, so it hasn't started moving yet. Then here's 1 second, 2 seconds, 3 seconds. Okay? Those are my velocity vectors. And then my acceleration vectors would look like this. This would be my acceleration the whole time would be 9.8 meters per second squared downward, right? So that's never changing. So at every moment in time I have the same exact acceleration. Those vectors shouldn't get longer. There we go. Cool? These should stay all the same length. There we go. Okay. So there's just a simple, what did I do here? There we go. It's just a simple motion map. Okay? And then maybe I'll draw some graphs. Okay? No, that's not going to work out. Gonna try that again. There we go. And I'm going to make down positive direction. Okay? That means my accelerations and my velocities are all positive. Okay? So my velocity graph would look like this, right? And my acceleration graph is even simpler to draw. It would just look like this, right? And my acceleration is 9.8. It's never changing. Okay? That's meters per second squared. This is time in seconds. And this is, what is that thing? You fix that. Okay, there we go. So I want to write time, seconds, velocity, meters per second. Okay? And then so this area here tells me my change in velocity. So change in velocity is going to be acceleration times time, right? Because that area is, or 9.8 times t. Okay? So that's my change in velocity. And in this case, the change in velocity is going to be the same number as my change in speed, because I'm just moving in the positive direction. So maybe I'll just simplify my life and say that's also a change in speed in this case. So if I drop something from a given height, I know this area here because that's my change in position, right? So that's a change in position. Since it's up and down, I'll call this delta y, and that's a triangle, right? So the base of that triangle, this part here, is t. The height is my change in velocity. Okay, so the height is my a times t, so 9.8 t is my change in velocity. So that area becomes 1/2 9.8 t times t, which is just 9.8 t squared. All right, so let's do some algebra with this and solve that for t. Okay, so I'll do that down here. So delta y equals 1/2 a t squared. Solve for t, right? So a t squared equals 2 delta y, right? And t squared equals 2 delta y over a. So t is going to be the square root of 2 delta y over a. I just, instead of writing 9.8, I wrote acceleration. Okay, so now if you want to find the speed of something after falling a known height, so you know delta y, the change in speed is going to be equal to the final speed, right? Which is going to be, because I'm starting from rest, my beginning velocity is 0. So my change in velocity plus my beginning velocity gives me my final velocity. My beginning velocity is 0, so my final velocity and my beginning velocity, my change in velocity and my final velocity are the same. Alright, so final velocity is going to be 9.8 times t. Alright, so 9.8 times square root of 2 delta y over 9.8, right? So there it is. That's going to be, that equation will give me my my final velocity after falling any height. So I can just plug in my height for delta y, and I'll be able to get my final velocity after falling that height. Okay? So this should be helpful for today's lab. Hope that helps you out. Have a good day.